Hello, I think we might be live now. Oh, let me just move things to a different window. Make sure I can hear myself as well. First of all, can I actually see myself? Yeah, I think so. Anyway, how's everyone doing? I hope you guys are doing well. Welcome to another weekend stream here in the Mark Gomez Codes or Coding with Mark Gomez channel. I don't even know the name of my own channel, which is quite interesting. And today we're going to be doing some more C++. In fact, we're going to be looking at how you can do performance benchmarks with C++ using Google Benchmark, which is a very kind of popular library that you can use to benchmark certain functions. And yeah, I guess that's what we're going to do. The library that you can use to yeah, there isn't anyone actually watching, which is a bit of a shame, but we're going to do it anyway, right? We're going to stream anyway. Right, I have my Coke Zero here as usual, and I guess the bottle gets bigger every stream. We need that caffeine, otherwise we can't code. And yeah. Anyway, so let's start. We're going to be working from the ECS repository that we made in the last stream. So for those who are kind of just tuning in now, if you are interested in looking at how we coded or we started coding the entity component system in C++, you can check out the last stream where we actually did it all from scratch. There's a lot of like template work, there's a lot of research work going into it as well, and we do have something that kind of resembles an ECS now, where you can have an entity and also you can have like an array of components for each entity. So that's kind of what we have now. We don't yet have the system part of it. In other words, the functions that are kind of applying behavioral code to each entity. But yeah, this is what we're working with today. So it would be nice for us to devise a little plan here for the benchmarking, right? Because what we got to think of how we can kind of benchmark this system. So if we just look at Excalidraw, I should have a little diagram of how this whole thing is implemented, and hopefully it's still going to be up here somewhere. Ooh. And where are we? We are here. No. Oh gosh, there's a lot of stream stuff. There you go. So this is the whole architecture so far of these. Yes. We do have entities, which are simply just kind of, I guess, just numbers, right? They are just IDs. That's what an entity is in our ECS. We do have the components. The components can be any kind of structure that you want. They can be any structure, any kind of class that you can create with C++. That will be a component. And you can kind of attach a component to an entity through the registry. So we have this big map. Let's call it, it's a class that is essentially working as a map. And this class here that's kind of registering everything basically just takes in an entity and a component, and it says, okay, right, this entity is now going to have this component here. And we store all of this with simple stud or std maps in C++. So the actual map here is actually wrong. So what we do have is the component ID here, and then we have a vector of pair of component or entity to component. This is what we are kind of storing right now. And yeah, this is our registry, and it's very easy actually when you think about it, but it did take us like quite a long time to actually code everything. And some of you actually did help me out quite a lot. But what we can do in the stream is we can include Google Bench or Google Benchmark, and then we can kind of benchmark how many entities we can kind of add at once, how many entities we can kind of get at once as well, how many intersecting components we can get for each entity. So for example, you may have a lot of entities with a particular component, let's say a circle component where you can draw the components on the screen. And we also kind of have like a rectangle entity. So we want to get all the components, all the entities that have a component, a rectangle and a circle component, and that's how we can measure. Like we can basically kind of benchmark the performance of that, right? because that's the interesting part of the component system. You can kind of request all entities for a particular that have a particular component and then process all of them. That is the strength here. So if that isn't fast, if that is actually very slow, then we're doing it wrong, which means we have to kind of refactor some code and make things a little bit faster, right? But yeah, I mean, the whole thing is implemented in C++. Again, you can look at the description of the video if you're actually interested in looking at how we implemented this whole thing, right? So let's get started. First things first, we're gonna use Conan here to actually bring Google Benchmark into our little build system here, right? So Conan.io, for those who don't know, and then you can go to Conan. Where is it? Conan Center. That's the one. So Conan Center is basically the repository that has all the Conan recipes for all of the libraries that are supported by Conan by default. So this is where we can kind of search for benchmark here. And the first one is going to be the Google one, the micro benchmark here. There are a bunch of other benchmarking libraries in C++. I'm sure that some of them are actually quite good as well, but I tend to use benchmark just because it's kind of simple to use and is very, very easy to include with Conan, right? So all we have to do here is basically bring on benchmark and put it into our Conan file. So we have benchmark. We should probably keep this in alphabetical order. Once we've done this, we actually have to install the dependencies, right? So once we have brought that dependency to our Conan file, we have to basically reinstall everything. So we need to do a Conan install whatever, debug. So the only thing that's going to be installing right now is Google Bench. And it should be a very quick build, hopefully, right? And actually, it's building everything from source, so it might be quite a while. Don't forget to stay hydrated, guys, in this heat. And I see that we have 3 people watching, so welcome to the stream, guys. If you guys have any questions regarding coding or anything, just feel free to pop on the chat. But yeah, welcome to everyone watching this now, and I hope you guys stay for a long time here. Of course, as soon as I call it out, people start disconnecting. But anyway, so we've got Conan, we've got Google Bench here installed. Now, I think on the usage it also says how we can include, so it's benchmark, find package benchmark, right? So what we can do here is we can have, let's say, binary, a test binary. Yeah, let's put it in the test, right? So we have tests here, and we have, oh, that's the wrong file. So we're going to put all the testing, all the benchmark stuff on the tests, right? So we haven't got one yet, but we can create a folder here for the tests. And in this folder, we're going to kind of create a CMake lists.txt, right? And what we're going to do is we're going to basically just, I guess, include an executable, which is going to be performance checks or performance bench or something. But first of all, we need to do the find package call to benchmark, and this will include the Conan library that we've just pulled, the benchmark one. And here we're going to put the target sources, I guess. I keep forgetting what the right syntax is for the modules, because we're using modules in CMake here, so the syntax is a little bit different as usual. But this is it basically. It's just that apparently. So we include this. We're just going to put that there, and then change the binary name here. Sorry, the target name to performance bench. Now we do want to include MAECS, which is our ECS library here, but we want to do benchmark here. Benchmark. Right. So that's how we want to include things here. And if we do have, oh, we forgot to actually include files, didn't we? So we just added the files here. So we can put a main.cpp here, and let's just add that file right now here, main.cpp, and we have kind of everything we need. The only thing that I'm gonna put here is enable testing and then add subdirectory tests. That should have triggered my CMake to actually add benchmark, as you can see here. CMake is actually finding my benchmark, the Google benchmark target, which is okay so far. And that kind of means that we should be able to include it here as well, right? So if you get IntelliSense working benchmark, performance bench, well, maybe not. So maybe we haven't completely done this correctly. So main.cpp. Yeah, first of all, what is the header name? That's one of the things that we can kind of study right now. So we're going to look into the Google benchmark documentation, because we're going to be referring to this quite a lot today. Although I've used it in the past, it's not something I do a lot. So yeah, we need to look at the usage. So include benchmark. That's it. So this is a very kind of easy example we can just copy and paste, and this should build in our current file here. So I guess we can do an import may ECS as well up here, because we do have modules enabled. What happens if we do build? So internal build target name results in an error. We'll see make build. And let's see what we're gonna get. So we have undeclared some function. Okay, yeah. So this is fine. We could change this to something like std string, I guess, for a creation of a string, right? String empty. Okay, and that build fine. It is worrying me that the IntelliSense isn't finding Google benchmark here. It's a bit weird. Let's just reconfigure and see if it resets. Just I want to be able to see what functions are available to us from the benchmark header. So, and it didn't work, but that's fine, right? So the idea of this library is actually kind of very easy. So when you use Google benchmark to do your benchmarking, first of all, you create a static function that is the function that's actually going to be doing all the performance benchmarks, right? And that function has to take this object here, state. This records the state of the benchmark, so you can then kind of save it later on to JSON files and stuff like that. And you can kind of you kind of have to iterate over that state, right? So this is kind of an iteration that will run many times for this particular function. And once this function runs many times, it will save the the timing information, the number of cycles taken for a particular function into the state. And then when you actually call benchmark here, which is this macro, then this function will basically run, right? So yeah, so let's see what we can do first. So it would be nice for us to have a benchmark the entity creation, or the entity component add function, right? So just for one, just see how long it takes to actually add one component to an entity. Now we do have up here, so we can kind of create a function for it. I guess void create entity with one component, right? And that will just be void. And in here we can do may ECS. We're not getting IntelliSense, which is very unfortunate, but we can kind of see what's in here anyway. So we do have registry. We have to create a registry in the first place. So we're not testing the registry function, which means we can kind of create it up here, right? So we can do may ECS registry. And then this is usually where we put all the components that are available to us in the registry. So let's create some components here. Let's say we create a structure called, I don't know, circle component, as we said, just for testing. So, an entity can have a circle that would be like drawable on the screen. And that's what having an entity circle component is kind of means in this particular case. And we're going to be benchmarking like how long it takes us to kind of attach those things to an entity, right? So that's what we're going to do here. So we're going to go for int x or radius x, int radius y. Oh, it's not radius, sorry, the center x. Center x and center y here. And now we do int radius, right? That's the component. Basically, that's what an entity can have. A circle entity can have. So in here, what we actually do is, let's say we first want to take a registry, right? So now, because the registry function can essentially by default take multiple types, right? Because you can have as many components as you want. That's what an entity component system kind of does. You can just have as many components as you want. Then we also have to make sure that we define this function that's kind of cascading it down as something that can take as many components as possible. You see why in a bit. So basically, so we can do this call here, registry, and we can do C's. That's it. Registry. Actually, that will be passed in, right? So may ECS, registry, C's 1, 2, 3. Pass that as yeah, pass that as reference. That's fine. And then in here, we're going to create that entity, right? So we're going to assign a new entity ID. So auto const entity ID. Now, do we have a way to actually generate an entity ID that's unique here? I don't think we do. So maybe that's a function that we can add here. That would be nice. Just a singleton for now, right? That's what we care. We don't really care about the best coding standards here. So yeah, let's add a function that will create a unique entity ID for us. An entity ID for us is simply a uint64. So that's what we're using to kind of identify an entity. So make sure we don't overlap, which means we just kind of have to add one whenever we get a new entity, right? Very, very easy. So let's do that. So we are going to return an entity ID here. So get next, or get entity ID, or generate, right? Generate entity ID. And this is simply going to be like a singleton function. So we're going to have a static std entity ID, and this is the start one. So current ID, set it to 0 at the start, and then all we're going to do is basically return cut ID++, right? So for those who don't know C++, when you do something like this, when you say a variable is static inside a function, that means that this variable is kind of initialized once when the function is first called, and it retains the value on the next call. That's basically what it is. So by doing this now, returning current ID++, we're returning the current value of ID, which will be 0 in the first call. But then the next time we would have incremented this. So current ID is going to be 1. So it's going to return 1 and then increment to 2 and so on and so forth. You get why. You kind of get why this works, right? But why did I do that? Just so we can kind of create an entity ID that's not going to clash with other entities, just for the performance tests here. So we can do ECS and we do generate. I'm wondering, is the test, is the chat working? I'm kind of very interested now. No chat so far. But anyway, welcome everyone to the stream. I know there's quite a few people watching now. So if we generate a, what's it called? Generate ID? I hate not having IntelliSense working in C++. It's the worst thing ever. And all of this is because we're using modules, by the way. It does work. Nice. Thank you, Tyler. Welcome to the stream, man. You know, cheap ways to get your engagement up. Just ask people to test your chat. Hello, Al. How is it going, man? Day of Redemption. Yeah, Al. Yeah, good to see you again, man. It's been quite a long time since I spoke to you, or since I've seen you. Oh no, actually, you were here last stream, right? I think you joined at the very end. Never mind. Forget what I said. Chat works. But yeah, the IntelliSense is not quite working here, and that's just because we're using modules in C++, and VS Code's IntelliSense doesn't really work with modules yet, and it's kind of painful. I have to go back and forth between the source files to see. Generate entity ID. So we have a new entity ID here. And what we want to do is this function should generate an entity ID and then also create one and also attach a circle to an entity ID, right? So that's what we're going to benchmark here. How fast it takes us to actually create an entity ID and then add it with a component to the registry. Now, I know that because this is essentially stored in a map, a stud, an ordered map or something like that. I can't remember what it is. It's going to be fairly slow. But as I change the map to a better type, I'm actually going to use dense map in a bit so you can see what kind of changes this makes. You'll be able to see that it's actually much faster than the standard unordered map implementation. So that's the idea here. That's what we're doing, and it should take us about 10 minutes to do it. So let's see here. So generate entity ID. So we have the registry. Let's just rename that because I can deal with misspellings. Registry. Now we do registry. Oh, wait, what? Registry dot. Why is IntelliSense not working, boys? I wish I had IntelliSense working. It's going to be set, right? I believe it's called set. Oh yeah, there are quite a few things we need to do for the setup of the component, but we'll do that in a second. We just do set here, and we say I think it's entity ID, yeah, entity ID, and then the component itself, right? So we can do something like very easily. So we do entity ID and then the circle component, where we have, actually let's, what do we have here? So center Y, center X is going to be something like 10. Center Y, oh, this is not the right syntax. I am not doing Rust, and I get annoyed every time I forget that I'm not doing Rust. So there's 2 spaces here as well. There you go. And then the last one is the radius, which is going to be equals to 50, right? Now, yeah, that should be a little bit better. So now we simply just do a component here. And if I'm not mistaken, it takes it as a reference. Yeah, it takes it as a constant reference. It just copies it inside. That's fine. Now that's good. Now, to create this this registry, we do need to do some setup here. So we need to actually create the registry to be reused in each iteration, right? Because what Google Bench actually does is, like, when you pass in the state here and you iterate over it, that basically means that you're going to be running whatever goes in here many times. And I don't actually know by default how many times it's going to run each function, but I guess it really depends on the number of seconds or the performance of the function. So if it takes too long, I suppose it's going to automatically not run it like 1,000 times. But if it's a very fast function, it's probably going to run it like, you know, maybe 1,000,000 times or something like that. And then out of that, it's going to get the average time taken. It's going to have like standard deviations and stuff that you can access. So that's going to be quite interesting for us, right? So in this case, we only really have a registry with one component in it, which is the circle one, right? I need to say how I actually use this. So yeah, I need to do something like this. This is a usage that we can actually kind of make better at the moment. So every time we register a component, every time we create a registry, we also have to, why is this all indented with 2 and not 4? Yeah, every time we create a registry, we also have to register the component itself, which doesn't seem right to me. It seems like whenever we create the registry, we should be able to do this automatically. So that's one of the things we can change in the stream, and I'm going to make sure that I put it here. So to do, make the component registration done by default when we initialize the registry, because that's something we can do. It's no biggie. I don't know why we have to do it manually here, but for now, let's just keep it manual. And yeah, and now we are going to actually create the component entity with the component, and we pass in that registry in here, or registry. Registry. I can't spell today, boys. Sorry about that. And yeah, and let's change the name of this benchmark. So benchmark. Benchmark entity creation, or component entity set one component. So a single component, that's what we're going to benchmark here, right? And then we can obviously put that down here as well. And this is it should automatically do the work for us, right? Let's see if we can build this. Hopefully we have no issues. Under my registry, yeah. This is what we get for not having the IntelliSense working. We're just going to have to rely on the compiler output. And now we should have been able to see here. Let's open a terminal. We should be able to see something in the build directory. So we have tests here. And there you go, performance bench. And here it is. This is what we kind of get. So with Google Benchmark, by default, you get this sort of output. So you can see here that the performance benchmark of that particular function. It says here benchmark entity set with one component. The time taken for each call of the create entity with component registry is about 717 nanoseconds, right? And we did this many iterations. So in each iteration, is worth reminding that the size of the map is going to grow, right? Because we're creating a new entity ID here. So it should be like a +1 every time. And the mean average of time, so we should have, at the end, we should have like 11,000. Is that it? No, it's 11. Yeah, it's a 1.1 million entities in the map. And, you know, the average time taken to add one entity is just under a microsecond. Yeah, just under a microsecond, which is actually quite fast, isn't it? But let's see how we do with dense maps, right? So one of the things I talk about quite a lot in the stream. So if you guys have watched my C++ streams a lot where I'm doing some performance stuff, I usually mention the dense map. So dense map is an implementation by this guy called Martin Leitner Unkel, and it's a very, very fast map, very, very fast map indeed. So this is available on Conan, so we can see here. So Conan, if we search for dense map, we're going to be able to find that. It might just be called map or dense. I can't remember what the recipe is actually called. Okay, we have an issue in the UI here. Let's see it. There you go, unordered dense. That's the one. So let's use this one and see how it works, right? So we have, again, we're going to be making some changes to the Conan file. We're going to be putting here unordered dense. That's going to be around here. And we're finally going to go on the terminal and then do another Conan install. And it's worth noting that we're actually running this on debug mode. So this is debug mode, still doing fairly well, right? So if I did release mode, it's going to be much, much better. But I'm happy to just kind of do it all on debug mode, just so we can debug things if necessary, right? Anyway, so we have that. I think the target that I actually have to include is unordered dense. There you go. So that's what we have to include on the CMake to actually make it work. So and this time I'm actually going to make a change to the ECS library itself. So in here I'm going to add a find package to unordered dense, and then I'm going to also copy this. And put it here. So target link libraries, and we have my ECS, so the ECS stuff, and then private unordered dense, right? So again, should get no issues here. Did we find unordered dense anywhere? I am wondering. There you go. So we have unordered dense, which means that actually on the ECS library, we should be able to simply replace the standard map implementation with the unordered dense map. My tongue is it's too much for me. Unordered dense. I can't say that. Can you guys say unordered dense 20 times without stuttering? Because I can't. So yeah, let's look at it. I believe, is it unordered? Unordered map. So we're not getting IntelliSense today. I don't know why IntelliSense is just not working. This is kind of annoying, but that's fine. We can look at the usage of unordered dense from GitHub. Unordered map C++ unordered dense. We should be able to find the GitHub page here. Yeah, so hash map. We're looking at hash maps. Ooh, simple hash. Yeah, I think what we actually need is uncurl include. Do we have? Oh no, yeah, uncurl unordered dense. I think this is the header anyway, something like that. Is that right? I can't remember now. I just wish IntelliSense was working, to be honest. Let's try and build this. It's probably not going to work, is it? Yeah, it does work. So that is the correct header. And this is definitely a third party. So let's put it up here, just above all the standard library headers. We should no. The thing with this library is that you should be able, and it's very easy. You should be able to just do a sort of drop-in replacement for the unordered map, right? So component ID, we should be able to just do a drop-in replacement with the actual map type. Let me just see the usage for it. Unordered dense. Is it map or something? I can't remember now. There you go, it was map, yeah. Ah, it was above here. That's the one. We should just be able to do this instead of std map, right? So yeah. So let's change all of these to uncode dense. And let's see how it goes, shall we? Now we should. The thing is, we should be able to do all of this, but I'm not sure. So add component. Now this is where we get a messed up C++ error, so we're gonna have to figure out. No matching function for call to add component. Why not? So add component is here. And we are taking, what are we taking here? Another map, yeah. So I haven't changed these. We should be able to just do that. Now, with a bit of luck, this is going to compile. I'm not too sure. Yeah, it seems all right. So everything's compiled. What did we get last time here? I think on the terminal. Let's just put this here so we remember what kind of results we got, right? So if we do, we've just opened Notepad. Hopefully I don't have any keys here to leak to you guys. There you go, just the stream today, that's fine. No leaking today. So this is with the stud unordered map, right? We ended up with this. Now let's see what happens when we run this on the dense map. Huh? Okay. Performance bench, there you go. Okay, so we get a lot of bullshit here, but what's the actual output? This is just to do with code coverage. I've accidentally enabled it. But you know, we don't get that much of a performance improvement on debug mode, so which is surprising. I thought this was going to be a lot better. So with uncle unordered dense map, this is what we get, which is actually, if you think about it, is higher than the stud map, right? So now the thing is, let's run this on release mode, right? So let's change this Conan build to release. We might be stuck here for a long time building things. Hopefully not. Hopefully not. And I hope this is actually very fast. But anyway. I think it's time to turn my spotlight on because it's getting quite dark here. It's actually gonna kind of rain quite a lot tonight. But you should be able to see my beautiful face now, all in white. Anyway, how are you guys doing? Are there many of you doing C++ today? I know that some of you do Golang. Talking to Al here. My keyboard is way too flashy. Yeah, so now let's build this with select preset. Let's build this in release and see if there's a massive change, because I'm not too sure now. So clang release. Hopefully this is actually gonna build with no issues. That's fine. I need to make sure that we're actually running things in release mode, because the preset, I think I made some changes here. There you go. So Conan release. Conan. Making sure that the libraries are being pulled in release mode, essentially when I'm not using the same third-party directory here for release and debug. But we're fine here. So Unix rel. Let's build and hopefully hope to God that this still compiles, and it doesn't compile. Why? Why is that? Unused parameter argc. Okay, I mean, we can just change this. This kind of means that I have flags enabled on release mode that are not enabled on debug mode. So unused variable. Let's just compile all of this. Let's just comment all of this out. So it compiles. Yoho might want to put a pin in this. I read somewhere that until you hit like 1,000 values, key maps are faster than until you hit like thousands of values, key maps are faster than unordered maps, because the constant factor of unordered maps is kind of high. Yeah, that's true. That's true. So yeah, if you have a very, very small map, so 1,000 might be even like too small. So if you go even to like 10,000, it might be quicker to just do a binary search over the hash, right? Because essentially when you're using an unordered map in C++, you're hashing whatever key you have there, and then you're seeing if that exists in the map. That hashing function, the hashing time is constant, but it does take time. So sometimes that is actually slower than doing a binary search if the map is small. But in this case, when we were working with an ordered map, we actually had on average 500,000 entries, because overall it was like 1 million here, and in here it was 729,000 entries in the end. So yeah, it fits in cache. So that's a good question. It really depends on the structure that we're using to save things here, because right now this ECS is saving everything in this format here. So let's actually take a look here. So the registry is using a map that is kind of using the keys, the component keys, which are essentially strings. I think in C++ these will be strings. Sorry, this is this one here. So we have strings as the keys, and then for each component we hold a vector of an entity and the component data in it. So in theory, the vector itself is cacheable. So like when we go over this vector, it is cacheable. Now when you access a map, depending on the number of entries you have, it can be in the cache. The problem with map is that it's not contiguous data, so none of the C++ maps, for example, are contiguous. So they are all in the not right next to each other. Like the key value pairs are not right next to each other, which essentially means you're not going to get a lot of cache hits. But I think that's the point of an ordered dense, though. I think this will actually make the cache hit more. But what we've noticed is that, for these tests, unordered dense was actually slower. And this may be, well, I think Yoho, I'm not going to attempt to say that name, but what that guy has said might be true. So the hashing function in unordered map here, so unordered dense map, might be slower than the hashing function of unordered map, up to a certain number of values, right? So we will see that, I guess. But anyway, let's continue building this. Unused variable, my rect ID. Wait, what? Registry. Yeah, I forgot to actually register the thing, didn't I? So we are looking at the app itself and my registry ID. So it's rect ID. Okay, this is just for getting it. Oh, okay. So we're automatically storing these things. Okay, that's fine. I thought that we had to do this manually. I thought that we had to register a component manually. We don't have to do that if we're just setting. So let's build it, and then let's run it again here and see what happens. So this is in release mode with dense map enabled, right? Oh, I don't know what I did there. What am I doing? Yeah, let's clear this again and run the performance tests, performance bench. So in release mode, how many iterations can we get out of this? So, no, this can't be right. So in release mode, apparently the time went up, which is interesting, isn't it? Very, very interesting indeed. How can the time go up in release mode? Oh yeah, it's because we're still in debug mode. We're still in the debug build. So Unix, release, Ninja, there you go. It's always a skill issue, and the skill issue is usually me just misspelling things, so yeah. Hello Slim, how's it going, my man? It's good to see you here, dude. So this time on release mode is something that I actually expect. So it takes 39 nanoseconds to add an entity, which is kind of very low. It's very good. In terms of iterations, how many iterations were we able to do overall? So it did 15 million iterations this time, which is good. So yeah, let's put this here so we just remember how long it actually took. So with uncle, these are debug, right? use a debug, and we're gonna just do a nice little zhuzh up here. Oh, wait, you can't put tab. You can't tab out. You can't put a tab here on. Oh, you have to do it line by line. Jesus Christ, why is this so bad? This is so bad. Someone please fix a notepad. There you go. I just wanted to do that, really. There you go. Now we're gonna go to release mode. And this is what we had for Anchor dense map, right? I just want to just leave it here so we can compare it in the end. And then we're gonna do the debug, the unordered map one now, and see if things work. Yo yo, hello yo again, dude. I hope you guys have your Coke Zero to accompany me in this stream, as usual. I'm still waiting for a Coke Zero sponsorship. I'm gonna keep saying that name until they sponsor me. Anyway, so let's switch again to normal unordered maps here, right? So we had dense map. Wait, this is the wrong binary. Wrong binary. Let's close all of this and just open the ones that we actually are interested in. So here, we're gonna change uncurl. I'm gonna just use Vim to do this. Unordered dense map with std unordered map. There you go. Thing should build again. I'm gonna leave the header there, doesn't really matter. And now this time, let's run it and see what actually happens in release mode. Oh my god, I keep running the wrong thing. I keep running the the Conan install script. But we should have it here. So 36 nanoseconds, which is interesting, right? Interesting, because that might actually be slightly lower. Yeah, slightly lower. We've stood an ordered map. That is very interesting indeed. So maybe it map implementation from the standard library is actually more cache friendly than another dense. So I'm actually gonna make the conscious decision to actually just use an ordered map for now. Why not? Let's do that. Or maybe it's because of the size of the map that we have. Yeah, I don't know. It's interesting though, isn't it? So we actually found that unordered map dense is slower for this particular use case, which means we're going to leave it as stood map for now. Now let's think about a few different performance tests that we can do here. Which compiler are you using? I'm using Clang. I'm using Clang with O3 enabled, I think. So this is the CMake settings, and if I look for release mode, release Clang Unix rel Ninja, this is the preset I'm using, which brings in the release preset. I thought it had O3, which is interesting. Unix make, Unix Ninja. I know GC versus Clang have slightly different performance characteristics. Yeah, I mean, you mentioned that as well, and that just made me realize that maybe I don't have O3 enabled, and I should probably do that. Let's do it again. Let's do it again. So we have, let me just make sure that I understand this, because I've written this CMake presets JSON like literally maybe a year ago, and I've been using the same one over and over again. So it just means that I forgot how it's actually all inheriting the other presets. So I'm using Unix release Ninja, which compiles with Clang and uses Ninja for the build system, and that brings in Unix Ninja and rel. Right, Unix Ninja and rel. So Unix Ninja should be up here. Yeah, we don't have anything special here. And release is there, build type is release. What I'm gonna do is I am going to actually put O3 here. And then let's reconfigure it. That's probably, you know, the reason why we're getting these sort of results. So yeah, let's recompile everything. So build. Okay, can I rebuild? clean rebuild. Let's just see if it improved anything. So this is the wrong one. Performance bench. Actually, O3 made it worse. I'm just gonna run it a few times and see if that's the case. Yeah, O3 made it worse somehow. That's interesting. Let's compile it with the uncle. So we're gonna change stud unordered map to uncle unordered dense map. And let's clean build everything, or rebuild. Just to make sure. Fuck. Also, I shouldn't be swearing. Sorry about that, guys. Oh. Yeah, see, with O3, then it is the case that Uncle is slightly faster from the looks of it. Not much though. There's a lot of like variance from what I can see. A lot of variance indeed. Yeah, I mean, I did one run before, so yeah. Try O2, O3, as O3 makes larger binaries, which sometimes can fit in the cache, etc. Yeah, that's true. That's true. Yeah, let's try that as well. Good suggestion. Now let's reconfigure and then rebuild everything. So the lowest run we actually got was 34 milliseconds here, and the lowest run we got for the stud unordered map was about 39 milliseconds with O3. Let's see with O2 what we actually get. So by the way, for those who are wondering, the O option here in the compiler just sets the compiler optimization level, so the level of the optimizer. So if you do O3, for example, in theory, O3 is the highest level of optimizations, which means your binary will be made in a way that the code is going to run as fast as possible. O2 is a mixture between performance and size, if I'm not mistaken. So it might fit things better in the cache, as YOLO. I'm just gonna say YOLO. YOLO will say. But in theory, O3 should be faster though, because that's what O3 does as opposed to O2. There are other differences as well, like you can have OG. So OG is a build that includes the debug informations, if I'm not mistaken. There's a size one as well. I think I can't remember which one. It might be OG. I might be confused here, but yeah, there's a build that you can optimize for size. So the size of the binary is going to be as low as possible. So as small as possible. So these are options that we use for embedded systems, for example. So when you have kind of microsystems that only accept like 2 or 3 megabytes of binaries, then you compile it with OS, I think it is, which is the size. But yeah, so we have that, and now O2 is here. Let's see if we made any changes, any differences with O2. Oh, we haven't actually rebuilt it, have we? Let's rebuild it. And obviously the actual time it takes for the performance benchmarks to run depends on my computer. So like it might just be that my processor is running more things like in a particular minute compared to the previous minute. So we're gonna get some results that don't really reflect the performance very well. So O2, yeah, we actually got a lower one. So we got 32 milliseconds as the lowest one so far for Uncle's dense map, which is good, right? Which is good. So let's see with another map now. Let's make that change. Oh, dense map, and we're gonna go to stud. Clean rebuild. I'm running out of Coke Zero, guys. Can someone like pay for my Coke Zero, please? Just give me a donation. I'll buy it straight away. Fuck. I can't burp on stream, can I? Let's keep it civil. So, yeah, let's see what's the lowest one that we get now. So 37, 30, 46, 39, 50. Yeah. Yeah, now I'm getting the gist here that Uncle dense map is slightly faster than unordered map. Now, if I'm producing this code for people online, so it's for me to release online, and people are actually using this and building it themselves, the question I'll be asking myself here is like, does it justify, or in fact, does the 3 or 4 milliseconds in entity additions justify adding an extra dependency? And in this case, I'll probably say yes, just because, you know, this is the bread and butter of an ECS. Adding entities and adding components is like the foundation for an ECS, which means that if you can optimize that as much as possible, it's worth it. So yeah, are you printing in code? Why not use Unix time instead? No, I'm not printing it. This is actually part of the Google Bench. So for those who joined in a little bit later, we are using Google Bench, which is a library by Google that just benchmarks C++ code. And it's pretty much, you know, quite popular. I think everyone uses it. There might be 1 or 2 libraries that are better. I've always used Google Benchmark, and that's kind of the one I recommend as well. But yeah, this does all the printing for you. In fact, let's get into some of the more advanced stuff here. So I know that this is nice, this output is nice, but you can also have things like JSON output. So you can kind of integrate this with something like a CI/CD, right? So you can save a JSON file somewhere, and then you can parse that JSON file and a SQL database or something like that, so you can compare it for different runs and stuff. So you can look for regression testing and shit. This is actually quite a nice library to use for that sort of stuff, and I've done that many times, and it works quite well for it. So let's actually see how we can do some of that, because, you know, ideally we would basically just focus most of the stream on Google Benchmark, because that's the title of the stream. So let's do some of that right now. Let's see if we can make some JSON output work for us. So I believe there is a usage guide or user guide somewhere, and we're gonna just user guide there. I'm going to read this. So output in files, output formats, right? Output formats. The library supports multiple output formats. Use the benchmark format console JSON flag. Okay, so basically it's already built in my binary, right? So I should be able to do benchmark underscore format in here equals JSON. There you go. So that's quite nice, isn't it? So what do we actually get here? What kind of JSON do we get? So we get a date and time, which is good. We get the host, I guess the person running it, which is my name. Number of CPUs used, nice. So it is automatically multi-threaded, I didn't know that. Megahertz per CPU is that much, which seems to match what all my specs are. CPU scaling enabled, false. I don't know what that means. There you go, the size of my cache here, the instruction, I don't know what that means. But then we actually get the benchmarks itself. So we get the name of the benchmark, family index, run name, run type, iteration, repetitions equals 1, iterations equals this menu. So basically, I guess we can probably set these things, right? So I'll be able to kind of set repetitions equals to something. Is that right? No. It would be nice to see where these arguments are defined, because I kind of want to find them out now. Passing arguments, there you go. Okay, yeah, it's just down the document somewhere. Oh no, these are not the arguments I'm in. I'm in the program arguments, but yeah, never mind. We'll continue reading this. So you get the gist, right? It's very easy to actually just set the output format here. And I guess you can send it to a file as well, because that's the next thing up that I saw here. Maybe not. The CSV format outputs comma separated values. Cool. There you go. Right. Benchmarks results to a file. Benchmark out and the file name. Or benchmark out specify the output format with benchmark out format. Okay, so that's a different one. So we can, you can see that you can kind of just save this to a file, a JSON file, quite easily here. Note that the CSV reporter is deprecated and the saved CSV file is not parsable by CSV parser. That's very nice, Google, isn't it? Specify benchmark out does not suppress the console output. Nice. Running benchmarks. I kind of want to see if I can set the number of repetitions. There you go. Reporting considerations. No, we're not going to find anything here. Set open teardown. We can have that. Same as, set open teardown are kind of the same as Google's unit testing library. So gtest, if you know what those are in gtest, it's basically the same here. That's what I can tell you guys. I'm still looking for repetitions. There you go. If multiple repetitions are required, request using benchmark repetitions command. Okay, so repetitions would be nice just so we can get like a better idea of how long things actually take. So it's benchmark repetitions, is that correct? If I do like 4 repetitions, let's see. Yeah, okay, nice. So the real time is there. Okay, so like I've got a benchmark for each repetition, is that correct? So 1 here, 2, 3, 4, 5, 6, 7, 8. Okay, right, so we've got standard deviation. Okay, so this has given us a lot more stuff now for some reason. So this has given us a benchmark set 1 component. I don't know what that is. Number of iterations is there. The real time in nanoseconds. E to the 1, so that's 41 milliseconds. Okay, I see what this is giving us. So it's like an entry for each iteration, right? For each repetition index. And then we also get the mean, the medium, and standard deviation. So yeah, this is a better benchmarking multiple times, and you can also see you know, the mean, the median, and the standard deviations, which are kind of, I guess, kind of like measures that you don't want to miss anyway if you're running things over and over again. So always use benchmark repetitions if you can, if your benchmarks are not too they're not taking too much time. You can see here that the medium for the what do we have here? Another map is about 38 nanoseconds, right? In fact, let's do this a little bit more just so we can get like a true representation of the time difference between Uncle's dense map and the stud another map. We're going to be doing this a lot. I'm sorry about that, guys. We're going back and forth in this library, and that's fine. Let's just do 10 here, just so we can actually get a true median and a meaningful standard deviation here. So the mean was around 40 milliseconds, right? That's what the mean took. And the standard deviation here, so how much it deviates from that mean, we have 2 milliseconds. So, you know, the highest one was around 42 milliseconds and the lowest one was around 38 milliseconds in this run. Now let's do the same thing with Uncle's map. Oh, there you go. So that's all we're going to do. We're going to rebuild this and we're going to rerun this thing here. So again, it was around 40 nanoseconds and then 2 standard deviation. Let's compare that with what we actually have here. Let's just clear this in the first place. Performance benchmark. And this is the Uncle one. I expect it to be a little bit lower just because we're building a release and O2 seemed to be the best for us, as YOLO suggested. So I'm expecting it to be a little bit lower. So the mean here was actually 34 milliseconds, right? Which is a lot lower than the standard implementation one. But the standard deviation, it deviates a little bit more. So it deviates by 3 nanoseconds, which is not too bad. I mean, the highest one was 37. And again, the lowest one was, according to this, was around 31 nanoseconds. So this is a massive performance improvement just by changing the map types. That's what I want to get to here. So just by changing the stud another map to another dense by Uncle, then you get a massive performance improvement. And what's cool with this library is that you can actually customize a bunch of things. So if you know the type of values, for the keys very well, you can kind of optimize it very well by creating your own hash function, which, yeah, it's going to make things a lot, you know, faster, because the hashing is probably what's taking the longest here. Anyway, so what should we do now? So we've done a little bit more of benchmark. I kind of want to, just to make this a little bit more interesting, I kind of want to show you guys how this library has actually been used, because we've touched on a performance benchmark in the ECS here, but we've not actually seen it working, right? So let's see if I can add a quick function to draw that thing on the screen, right? So we had this bit of code that's here from the emulator that we were creating with C++ again. So all this does is like it initializes a window, and then we also have we also just draw some stuff on it, right? So let's just initialize the window here and not do anything else for now. But what we're going to do here, the idea is that we're going to get all the entities with circles and draw the circles on the screen, right? That's what we're going to do here. So yeah, let's do that. Now for this, I probably want to pass in my registry here. So yeah, let's do that. So template, type name, my components, and then I'm going to pass in my ECS registry, and then I have C's here. Oh, registry. And we're probably gonna have to like, I guess we're gonna have to protect this because it's gonna be multi-threaded. Nah, we don't need that now because we're not doing this in a separate thread. We're gonna be running this draw function in the same thread, so we don't need to worry about multi-threading for now, but we will later, which is gonna be an interesting thing. So how do we worry about multi-threading in our registry? So we got to be able to think about how we're going to protect the registry from being accessed by multiple threads later on. I have not thought about that yet, but I guess that we have a draw circle. So what do we do here? So basically what we want to do is we want to do a registry.get, and we want to get all the entities that have a circle in it, right? So let's do that. First of all, let's change all this. Let's put all of this at the very top because we're going to need those definitions on the draw function. Oh, let me just recopy that. So we're going to put all of them in here. Yeah, why not? In an anonymous namespace. We can do that. And I need to figure out how to use the get function. So how do we use get function? This is how we use the get function. So in fact, we're going to do here, we're going to put that there, get entities with the circle, we get my circle ID. We need to find out how to, oh yeah, we do have a function. So registry.get. Oh no, registry.id, that's the one. Circle there. Yeah, it's a little bit annoying how we actually get the entities at the moment, or the components, because you kind of have to know the component ID, which you can only get with the registry ID here. And essentially what that does in C++, it just takes the type ID of things and then gets it from the map of type IDs that we have. It's nothing too complicated, to be honest, but it's a little bit annoying that you have to do this at the moment, manually. Maybe we can make this into something a little bit more usable later. So my circle ID was the one. And then we can go through each entity here, right? So the idea is to go through each entity, I believe, and then we can, so for, so each entity is entities with circle. You see, that should really return, that's where I should be changing things a little bit. Because entity get will only return you the entity IDs, right? What I want to do is I want to return the entity and the components as well. Which means I might be able to get rid of this function in the end. Because all I needed this function for is just to transform the pairs of entity IDs and components to just a vector of entity IDs. So yeah, that will be even better for performance, actually, for sure. So what we're going to do is we're going to have a stud pair here, entity ID, and then I guess the component, or the C's here. Wait, what is this called? Yeah, but we don't know the type, and that's how I did it. Oh, okay, I see what's going on. Yeah, this is annoying. This is annoying now because I can't say that I'm going to return a particular component here because I don't know the type here. This is not a templated function. Well, I guess we do, right? We have C's here, so we can get Oh yeah. Never mind. We can do that. Forget what I just said. Thank you for the heart emojis. So, I'm very happy that you guys are enjoying the code. Oh, by the way, are you guys excited for bank holiday? I know Slim, you're in the UK, right? So you're probably very excited for bank holiday, dude. Don't have to work tomorrow, which is amazing. 100%, yeah. I actually forgot about it until today. My partner was like, yeah, there's a bank holiday tomorrow, but like you don't have to stream today, you can stream tomorrow. And I was like, no, I'll do it today anyway. I'll do it today so I can prepare for work tomorrow. There you go. So, right. So what am I doing? So I'm returning a component here, which is basically a stud variant, right? I believe. How did I define it? Component ID, component name type, just a variant. So stud, a variant, and then I have C's here. So instead of returning entity ID here, I'm going to actually return a stud pair of stud variant of those C's there. That's all. Like if I return this instead now, it's very easy for me to just convert whatever variant I return to the type that it should be, right? It should be actually okay. So I, in fact, can just kind of remove this now. So transform entity IDs. Let me understand what this is doing first, because I have no freaking clue what this is doing. I wrote it last time, and I'm pretty sure I rushed it all in like 5 minutes because I wanted to sleep. I think the stream that I made is I kind of took about 3 hours to do this whole thing, which is a very long time. We needed to write 80 lines of code. But yeah, I was very tired in the end, and I kind of wanted to sleep, and I did it very fit and very fast, and it just worked. So now I have to actually understand my code, which isn't ideal. So first thing I'm going to do is change this to a stud variant of C's. And then this can be the same thing. So okay. So find component ID and entities ID. So what this is doing, so I think this is getting like an intersection, because essentially this function gets whatever entities you have that contain all of these components here that you send, right? In fact, this should have really been this. I don't know why I didn't do that. Which means that we have to get the intersection of all the entities that are contained within each component that we pass in here. And this is essentially what we're doing. It's just basic, simple maths, simple intersection. And we're actually using the transform or the set intersection here to do that in C++, which is a very nice function that we don't have to write ourselves. So yeah, so instead of transforming, the next component is going to transform entities ID. Yeah, so what do we do here? What is found? Found is going to find me component ID. I'm so confused now. Jesus, I wish I didn't write this code. So the next component is basically all of the entities for a particular component. That's what I can get here. Right? Yeah. So found.second. So basically what I can do is I don't have to do this anymore. Transform entities. I can just do that. And the set intersection, the result is what? Transform entities. Yeah, so the result, we can kind of just do that now as well. Same thing. And then we get the set intersection. Okay, yeah, this should in theory work now. But I'm sure we're gonna get like a massive templated error. You ready for it? You ready for it? Yeah, there you go, boys. Now, How many of you look at this in C++ and think like, this is really good. I love programming in this language. Seeing error after error after error and no meaningful error message just makes me really happy as a person. So that's how C++ makes me feel. Use template keyword to treat ID as dependent. Okay, let's see. Registry.id, so it brings me an optional. What? Use template keyword to bring, wait. Template keyword to treat ID as a dependent template name. What? How do I call ID here? I mean, you know, it makes zero sense. Like I read this and you see that I have no idea what this means. Yeah, this is exactly how I call it, which is interesting. My lord. Error. Use template keyword to treat ID as a dependent template name. Why is registry not a thing? Oh yeah, registry should definitely have the ID function on it. What? I'm gonna Google this because I can't remember seeing this error in C++ before, and it makes zero sense on the context here. Like I have no idea what this even wants me to do. Zero sense. I've been playing with Clang a while. Yo, hello Robin, how's it going, dude? You joined just at the right time, man. Just at that debugging time that we get stuck on for like 10 minutes. I mean, these answers are giving me a headache just by looking at it. I don't want to look at this. I don't want to look at this at all. So consider the following code example. I would expect to have to use the template keyword here to guide the compiler to treat variable v as a template. However, MSVC. Oh yeah, never mind. C's type name, template type name. Yeah, what is going on here? Oh yeah, I don't have emulator. Oh my god, that's why. Jesus Christ. Do you guys see the problem here? Like, this is something that was left over from the code, but in no point did the compiler tell me. Oh yeah, it did. Never mind. I'm just dumb. I'm just completely dumb. If I actually read the first error message, I would have known exactly what it is. It's just this, right? There you go, boys. That should compile now. Still doesn't though. Oh, and it's still the same error. I thought it was gonna actually fix itself magically, but magically. Yeah, so what does this mean? Use template keyword to treat ID as a dependent template name. And this is a GCC error. Why is it a GCC error? I'm compiling with Clang. Oh yeah, that is correct. So it should really be registry. And we still got the same issue. And it is circle, right? Maybe I had a typo somewhere. Nope. Sickle. There you go. Sorry about that, guys. I need to take you through this. You need to know the pain of C++, and it's still... It's not going to work if I force it to be a type name. Error expect to qualify. Like, why is this not working? Why the hell is this not working? It's literally the same line of code as what I have down here, right? So my circle ID, literally the same line of code. Is it because it's a constant and ID is not a constant? If this is the error, I'm literally gonna I'm gonna stop the stream. If it's because it's a constant, it's not telling me it's a constant. It is exactly that, isn't it? So if I change this to a const now, Jesus Christ. You see, at no point did the compiler tell me a function that does exist, but is not right qualified. It's not the right qualification here, because I'm calling it from a const object, and that function is not a const function. So very annoying indeed. So let's see if this compiles. That's it, guys. Yep, boom. No, it doesn't. It doesn't. I thought that was it. I was wrong. ID is now a constant. So type name C. Use template keyword to treat ID as a dependable. I don't understand. I simply just don't get why this is giving me this issue. And if I remove the const here, out of interest, if I remove the const there, does it work? No. Oh Lord, yeah. This is going to be a wild one. Now let's go back to Google and see. Template was unexpected here. So I have a couple of structures. Let's see what they're doing. So they've got, let's see if it can be translated to our code. Don't you need another template? The template C is for the registry, but you need a template for C function. I'm not that great with C++. So Al, yeah, good question. No, because we have this. This is the template here. So this is the one, right? That's the thing that's telling ID which template to use here for C, right? Yeah, obviously on the declaration we do have a type name C here, which is here. But when you're calling it, this is how you do it. It's kind of the same as Rust. It's very, very kind of similar. So yeah. Let's see, maybe this answer, there you go, foo int. It's exactly what we have here. So they've got a template type name S here inside a structure that has a different template T. And they create that template C here with B, and then they have foo with int. C is a template, B is a dependent type. The compiler cannot know foo is a template or not. You need to tell it. C template foo. Oh, I have seen this before. This is something that I don't really use a lot, but yeah. Okay, that's better. That's much better. So that bit did actually compile. Yeah, sometimes you have to tell the compiler that the function is a templated function that does not depend on the overall templates here. This is one of the C++ intrinsics that people just forget. People like myself just forget all the time. So yeah, welcome to C++, boys. Welcome to C++, where you spend half a millennia just looking for the fix, and the fix is something entirely different. Yeah, I kind of want to refresh my memory now on this syntax, because without the compiler would pass the call as c.foo less than yeah, instead this will pass, the compiler will pass registry.id less than circle more than this, which is very annoying. This is messed up, isn't it? It's messed up indeed. But I don't understand why this is not a problem down here as well though. Maybe this is because I guess in here we know that rect is a dependent type here on the overall one. And up here we don't really have that because this is an arbitrary template. So yeah, very annoying, but anyway, so we have everything that we need here. We can remove all this code. We are going to look at the cheat sheet for the graphics library that we're using here, which is Raylib. So we're going to look at Raylib's cheat sheet. Who was it that suggested Raylib to me? Was it one of you guys? Was it you, Al? I can't remember now. I ended up liking this. Raylib C++. It might have been one of the guys who used to join the stream back in the day, but haven't really showed up anymore. So now we are going to look at cheat sheet. So where is it? So we have Radial. Wait, where is the get started document? There you go. That's what I'm looking for. So draw circle. So draw a circle. This is the one. So we have color here. We have center, float, radius. Yeah, that's what we need, right? We kind of just want to call this in here somewhere. Right. So we have draw a circle, and then somehow we're going to get the component dot x center x, the component dot center y, and the component dot radius. And we can finally uncomment this color thing here that we're actually going to use now. So this is a color palette that we're going to use. This is very basic graphics because we're using this for a Super Nintendo emulator. So that's where I'm recycling the code from, basically. So we have color table. Let's pick the fifth one. I don't really know which one it is. But entity should be a stud variant, right? So we can convert a stud variant to a particular type now. Let's do that. I can't remember how to do it, so I'm going to use the CPP reference. I'm pretty sure there's a function called get in variant. Not too sure now. So what is this variant? We have index, we have visit. Yeah, ideally we want to call visit to turn things back into components, but we're gonna get instead. So const per size ti. Let's see how we use this. So get float. Is this gonna return me? Yeah, it returns me a reference. Nice. So I can do something like auto const or circle. Component equals entity dot get circle. And this is basically it, right? I think this is kind of it. Let's include thread here because we need it for this leap, as we just saw. We need chrono as well, otherwise it's not going to compile. Okay, and yeah, let's just call that with the my registry. Now we should get some circles drawn up on the screen now, which will be interesting, right? I don't know which positions they're on, so they're on 50. Right, declaration of variable circle without alter requires. Oh yeah. My bad, compiler. My bad. I realized that the working space that we have here for the code is actually quite small, so I do apologize for that. Oh gosh, error after error. So error use template keyword to what the hell? Fine, we can use that if you really want. Error invalid operands to binary expression. Now this is an interesting one. This is an interesting one. If I do specify that it's a variant there, do we still need to put the template here? That's the question. Yeah, I still do. Template specialization requires template. Let's just move back to whatever the hell it was. Why is get not working though? That's a question. Oh, stud get. That's why. That is why. So we really have stud get circle here. Okay. No matching function call to get. That is because we don't have variant in here, I believe. Yep. We're getting there, guys. I promise we're getting there. And things will draw on the screen. Once it compiles. Once it compiles, that's the problem. So error, no matching function called to get. No candidate function, template not viable. Requires single argument in. Oh. Like, why? Why are we not getting this? So it's defined in the variant header. And the call is just this. We just do a stud get here. I'm not sure why that's not working. And we pass in the entity itself, right? Oh yeah. I thought you guys are here to spot my mistakes. Thank you. Okay. Oh, Lord. So error, invalid operands to binary expression. So we have variant circle rect position, aka const, and const circle. Just tell me what it is, please, for the love of God. Is it going to give me an actual error here somewhere? How long does this go for? Any bets? This is one error, by the way. This is one single C++ compiler error right here. Look how long we have to scroll for just to find the end of it. Couldn't match const. Reverse iterator against variant. Okay, that's fine. It's still going. We're still going. All I'm doing here is I'm trying to just basically just get. So entities in this case, where are we? Entity is a variant that has circle in it. So I'm trying to get a circle structure out of the component. And that's right. That's what I'm trying to do. So why does this not work? Oh. Why does this not work? Stud get entity. Wait, what the hell am I doing? Why did that even compile? Why did that even compile? Okay, that's better now. Right, this argument get has no type. Wait, what function is not marked? We're getting a different one now. Oh Lord. What do we have here? So invalid operand to binary expression, that's fine. This argument to member function get has type const max, but function is not marked as const, yeah. That's fine. We'll get there eventually. Okay, now we're back to square one, which is the variant error. Can we fix this today? Invalid operands to binary expressions. Const val alternative and const. So somehow this message tells me exactly what it is, but I'm failing to see. Some variant alternative. Entities with circle. What is that returning me? This is returning me a vector of pair. That is why. That's why. Jesus. So this should really be something like entity and the component. There you go. That makes more sense now. For those wondering, the issue that we had here is that this function here, get, is actually returning me a vector of pairs. Each pair has an entity and the actual component, which is the variant, you know. But of course, as anything with C++, it doesn't tell me exactly like what the error was, and we still have we still have an issue here. So yeah, really, we want the component there. And that's fine. Okay, we're getting there bit by bit, but still. Invalid operands to... Okay, so let's... Why can't we get rid of this? This issue is just too much for us, isn't it? And also, why is it on line 1? Why is it on line 1? Invalid operands to binary expression, aka const. Circle and const, anonymous namespace circle. Variant alternatives. So we do have the right variant here, which is circle and rect. So somehow it's doing a binary expression? Wait, what? This can't be right. This can't be right. No. Stud get circle. Huh. So it's basically doing... Like, what the compiler is doing is like, it's giving me this. It's doing stud get, which is obviously a function pointer, as you can see here. Yeah. And this is comparing this less than circle, which is kind of what the template does, really. Which is annoying. Like, why do I have to do this? So yeah, let's see if we can fix this code with the template keyword again. So stud get invalid to binary expression. And this is not what we want. I do wonder if it's something to do like this. Does it work? This will not work, will it? Unqualified template, yeah. Does comp have a get thing? So if I do something like comp, so can I do it on the component directly? That's the question. So if I do comp dot get, I do circle, but I put a template in it. It is going to be happier for some reason. Nope, still invalid operands to binary expression const. Is it not going to say which line it is? That would be nice though. No member named get in stud variant. Yeah. So we might just be stuck with this. All I wanted to do is just to draw something on the screen, and as soon as I want to do something happy on the stream, I get hit with a fucked up C++ error. So we do have to call stud get, right, which is in here. Get pair. And we don't want the pair though. Just making sure that we actually are using this properly. So where are we? Stud get variant. Yeah, there is nothing really. Maybe what if we pass in the stuff here automatically? So we're going to pass whatever the registry should be in this case. I'm thinking that this is probably the issue. So circle, rect, and what was it again? Position, right? Let's hope that this kind of works now. So stud get circle with the component. For some reason, that variadic argument is kind of interfering with the actual templates in the function, I think. But no, that is not the case. Invalid operands to expression. Line 67. This is the one. So registry.get autoconst instantiation. So this is the issue here. Maybe it's on the wrong function all along. That would be funny, wouldn't it, if I'm actually looking at the wrong function? Yeah, it was the wrong one. Oh lord. Is it the same error actually? Yeah. So invalid operands and use variable my circle ID. But if I put template, it works. No, it still doesn't work. I'm not gonna lie, guys, I'm kind of stuck. I'm kind of stuck and I don't know what's going on here. Because this call is exactly the same call I make down here, where we do have all the types and things just work. So my question is, why is this, what is making this different from the call down there? The only thing making it different is the const here. That's what I can say. So this is the only difference that I can kind of see. Let's just copy all of that. I mean, let's comment all of that. So without the const up there, does it link? That's my question. No, without the const, it still doesn't link. And use variable my circle ID and invalid operands. But why does it not link? I'm kind of tempted to just Google the whole thing now and see if someone else has done that for us. Because I'm dead stuck on this. Really, really stuck. And this is not nice. Yeah, none of these are templating issues, which is the problem really. Template error, invalid operands to binary expression. There are two things wrong with your code. This is a non-deductible context. Yeah, it's something to do with, I guess, compilers trying to deduct the template argument, but not being able to. This is not the one though. We don't have the same issue as this one here. Yeah, interesting. I mean, this won't be the same either because there's not really a template to the class. Jesus, we are dead stuck. Dead stuck. Let me just stare at this code for a bit longer and hoping it goes away. Oh. That's one of the things I hate the most in the stream, by the way. When you guys are watching me, and there's maybe a handful of you, and I get stuck on something because it's just really annoying. I know that it's boring for both of us to be watching me, and for me to code this as well. So that if there's one thing I dislike on the stream, it's getting stuck. Especially on things like this, where I have absolutely no idea what the issue is. So, but that's just part of coding, right? I guess it's good to show people what you're gonna get. because what you see is what you get. So anyone who's coding out there, especially, I know that some of you have done this for quite a few years, you probably get into situations like this every day, don't you? It's just part of it. It's just part of coding. But it's usually a lot quicker to figure out though when you have a nicer language. Valid operands to binary expression. But the thing is, like, what the hell? If I reduce that to just the call of the function, so just the function ID get, then I am still gonna get that, right? Yeah, invalid operands here. So if I can fix this issue, I can fix the whole thing. Variant relation function template. Well, and the error is while substituting the juiced template argument into function template as test. No instantiation of the class. So before the fix was to just do this. Oh gosh. Not only am I stuck, I'm actually very, very tired. Indeed, Robin, that emoji describes my mood right now. Of all the things that I didn't plan on getting stuck on variant stuff today. So what? Invalid operands to expression. Template, registry template. But I don't understand how... And it is this function, right? Because if I just comment it out, the things still build. No, wait, where is it? Okay, so the code issue might actually be somewhere in here then. I just hate how it doesn't tell me exactly what it is. And that's why it's on line 1. It's on line 1 because it's coming from an import. So wherever we had the variant, this is the point, the issue here. Because C++ won't be a man and tell me exactly where it is. So I gotta do the compiler's job here of bisecting all the changes. And by the way, when you're stuck on something like this is what I do to kind of solve myself, right? I've got absolutely no idea what the actual problem is, but I know for sure that this is probably the cause now after commenting out all of the code that we had in the other function that was suspected the issue. I probably know that this is the issue, right? So if I've added like a pair here and it returns a variant, you know, good enough. And I've added all this code here. So I'm going to start commenting each line out to make sure that we know what the issue is, right? So for example, a big suspect is this one here, right? So the for loop that's actually doing stuff. Let me see if I can compile it without those lines. And it does compile. That message has disappeared. So I know that the issue must be in here somewhere. And this is kind of what you do. You just bisect it. You just kind of bisect it until you find the culprit, right? So is the culprit the simple creation of these two vectors? Let's see. Probably not. It is. So component ID. So components, what is it? So this is a vector of error type. Ooh, that is interesting. So error, unused variable component ID, but what's the actual error though? What is the actual error? Right, so yeah, this is just an unused variable. I'm gonna kind of just uncomment this for now. No, I'll leave the flag there. Let's... Oh, for components ID. No, yeah, I kind of need to remove that just so I can bisect things. Where are my flags at? Here. Unix make, Unix Ninja, W error. let's just remove W error for now. We're going to add it back later. Okay. So yeah, we have the warning there, but it does compile without it, right? So yeah, we have the warning, fine. Now, is the issue this particular bit here? So what am I doing here? I'm finding some entities, finding a component in the entities map. It's not going to be the issue either, or it might be. Never know. Okay, that's not the issue. So the issue is probably going to be the intersection here, which is it's going to be fun resolving this. Into result. Let's see. And there you go. So the issue is this thing here. And I kind of get the gist now. I kind of think I know what the issue is. So this is running at set intersection on all of the variables, the entities or the objects that are inside the result and the next component, right? So it's kind of building up the intersection as we go on each component. But we now have pair. And pair probably does not have a binary equivalent operator here, right? So that's probably the issue here. Now, I would have never found out by looking at all these things here. And C++ just needs to improve their compiler errors. But what I'm going to do now is I'm going to see if set intersection has an option where it takes a lambda to kind of compare things, right? Because it probably does. Usually it does. So set intersection here, there will be an option with a lambda. Compare, there you go. So just at the very end, this is what we do. So this will probably solve things. Yeah, it's a very annoying problem indeed, but yeah, what can I say? So compare comp. Let's see what the values are. So compare must meet requirements for compare. So compare, comparison function object, i.e. an object that satisfies the requirements of compare, which returns returns true if the first argument is less than the second. Okay, so we just have to do a simple kind of comparison here, right? Which will be kind of something like this. So return, actually, yeah, result or first dot first less than second dot first. Will this resolve things? I believe it probably will now, but we'll see. Yeah, there you go. So that's how you debug something you have absolutely no idea what it is by just kind of bisecting things. So in the case of C++, where you have really shit compiler messages, so compiler errors, you kind of have to do this quite a lot, which is really annoying, but it's just what we have to do. Now, this is not something that was easy to debug, I'm not gonna lie, this is actually quite a hard one. And I could have spent hours on it. It's just how I could have done things. But I'm glad that we finished it. So all of this just so we can draw things on the screen. Very easy, right? So undeclared identifier myCircleID. So myCircleID, right? I'm actually sweating after the debugging session, you know. That was interesting. So yeah, I mean, we should be able to draw circles now, right? So if we run the app, let's see what happens, shall we? Okay. Oh yeah, no, this is the wrong one because we're actually not running the release stuff. So Unix release, there you go. I know that because VS Code nicely tells you that the main.cpp file is newer than the module itself. So now we should be able to draw some shit on the screen. Okay, see, and then we can basically draw components now. So if I were to add a new object that has a new entity that has a different component somewhere else, I can do that as well. So you see how this is like kind of implementing a system. Is not really implementing a system, by the way, because really what we're doing here is we are kind of, yeah, no, we kind of just have a function that works on a component. So I guess that is a system by default in an ECS. So yeah. But yeah, let's add another component here and see what we can do. So we have my circle ID here, entities with that. So let's see if I can add another one. So let's add another circle. So my registry dot set, and then let's add to 3 circle. Then we have, let's just rename things here. Center X, center Y, and radius, right? So we have center X, let's say it's now going to be 100, and center Y is going to be 100, and my radius is going to be 200. So it has a 200 radius, which is quite big, isn't it? But this should actually bring me 2 circles being drawn on the screen now. And this is kind of showing you how powerful an ECS is, because all I did here, oh, there you go. So it's actually very, I'm not sure if you can see it, very, very big, and excluding the other one. So let's put it down there, right? But you can kind of see how it's very, very easy for me to add a kind of renderable component to any entity. This is the power of it. What size is my screen again? I can't remember, just so I can kind of make things look a little bit nicer, right? So init window 512 by 512. So let's put it right at the end. So 512 is there, and 512 here as well. Let's rebuild this and then actually draw it on the screen. So it should be at the very bottom now, hopefully. And here we go. So you can see how easy it is to do things, right? And extending this is very, very easy as well. Like I've got my circle. But let me actually put back the W error here, because I actually want to make sure that we don't have any unusable variables. So if I were to kind of extend this a little bit, so all I have to do is just to change my component itself. So I can do something like, you know, int or std.size_t and then the color. And this refers to, I guess I can say something refers to color palette here, right? And I can say like where in the color I want to draw it on. Because I have a circle here, it's very easy to do. So this will simply be circle.color. And yes, I'm doing this with the British spell. Can piss off now. I'm joking. I love my American friends, so. But anyway, so every time I have a circle now, I should be able to say, you know, color is going to be equals to, I don't know, the first color in the palette, and then the other one here is going to be, I don't know, the 12th color in the palette, right? Easy. And it's the same thing for the squares. So like if I wanted to kind of do the squares now, what I have to do here is I have to get all the entities. So this is the rendering loop or the system for the circle. And I can do the same thing here for a square. It's just as easy for me, right? Now, I'm not claiming this to be like the most performant ECS ever, but you know, it does the job. So now I should have 2 different colors, hopefully. There you go. It just so happens that color number 1 and color number 12 are, well, 1 is gray and then 12 is white. But let's do another one for the square as well, right? So ideally these things will be like proper systems where you have like maybe a class or a function that just runs like the rendering stuff for a circle and whatnot, and one that just does for the square. But yeah, we're doing it all in here, it's fine. So this is the rendering loop system for the square. And I'm gonna have to use a cheat sheet again to get the rendering here, so we can see how we can draw rectangles. Yeah, so draw rectangle, position X, Y. I guess this will be top left, so let's go for this. This is the call that we want to make. So we kind of want to make this call now. we want to make a rect call here. So we have entities with circles, which will be there. We're going to do the same for entities with rect now. So we're going to get all the entities that have a rectangle component, and we're going to make this call here. So draw rectangle. What was it? Draw rectangle. Ooh. So we have top left, right? So top left. Wait, should this be X and Y? I think it should have been X and Y, right? I'm not sure why I called it top and left. But let's assume that left is X. So we have X here, and rect at top is Y. Now what else do we have? Int, so rect.width. And we have a height as well, hopefully. Width and height, yeah. There you go. And the color table, again, I could put a color thing here, but what's more interesting is I can put a color, I can actually create a color thing here. So a color component, which is probably the best way to do it. So instead of like having a circle, a color in the circle, I can also just say I want a color component, right? And then this will be the stud size t color component that would refer to the color palette index, right? And all of these things where I say I want a circle here, I can also do a color thing here. There is some setup that I have to do right now. It's kind of annoying, I know, but I can kind of just do my color ID and color here. This is the setup that we still have to do manually, but we can turn this into something that's done automatically. So we don't have to refer to the class ID anymore. Let's remove that again. So in here, in number 0, I'm gonna add a color, right? So this first circle is gonna have the first, no, let's do the second one for the color. Just looked a little bit better, didn't it? And in here, I'm going to also do for the third one, so the color ID. Okay, and ooh. Okay, so those two circles should have colors now, and it's the same thing with the other ones, right? So if I were to put number 1 here, so my registry, I have a rect there, and I have a circle dot set 1 rect. What do we have? I say top is, I don't know, 300. Left is going to be 400. Oh, this isn't Rust. Come on, this isn't Rust. Left is equals going to 400 here. Width, let's say 50 and 50, just for a square. And I can also set a color here. I have to set a color, really. So now I'm going to be changing my system a little bit. So it only draws things that have rectangles and colors, and things that have circles and colors. So you can see the true power of an ECS, because we're going to be like filtering those things, right? So color, okay. What am I doing here? So color top. No, this is not what I want to do. What is going on here? There you go. And let's say that this color ID is going to be, I don't know, like column number 10. We don't have that one yet, right? So just to make sure, 3 has circle and color, 1 has rectangle and color, 3 has also got a rectangle and color. Maybe yeah, each one of these is going to have a different color. So you can kind of see that some entities have like two components. So some of them have a circle and a rectangle, and some of them have a rectangle only, and some of them will have a circle only, and they all have different colors, right? So let's build this and see. Oh yeah, what's going on here? No conversion from color to const component rectangle. Yeah, that's because we've created a new component, but we forgot to actually say to the registry that we want to allow a color here as well, right? That's what we forgot. And at the very top, we also do a color there. Let's change it to const again. And again in here, we kind of need that color ID, right? So we kind of need that my color ID. And if we haven't broken anything, this should still work. This should still work. I might say, oh, what am I doing? So yeah, I'm just changing the entity get function here just slightly, so just so we can get the ones that have a circle component and a color component, and it will be the same thing for this as well. So, ooh, what do we have here? Yeah, now we also have to get a color component. Okay. And the same thing here, we're gonna put that my color ID. So it gets all the entities that have a circle, oh, should be a square component, right? So my rect ID. So all the entities that have a rect ID and a color ID, right? And at the very end here, we're gonna have to do the same thing here. We're gonna have to get that color component out with get. And I think that this should be okay now. Let's see. Let's see if it compiles. I assume it's probably not going to compile because we forgot something. No name color ID. Did you mean color? Ooh. What? Color. Let's just change it to ID, shall we? What is it called before? Color ID. No. Color.id, color.id. There was some in here too. I just don't want to make it too repetitive, so it's color.id. Okay, what are we getting here? So color E. I don't know why I had the E there, but okay, one last error. Which one is it? So color, yeah, we don't have color anymore there, as we created a separate component just for the color. And you can see how you'll be able to store things like a mesh for an entity. So like you can have an entity component that has mesh information on it. So my color ID, color, what is going on here? What? Unused variable, my color ID. Okay, that's fine. And now if all went well, we should be able to see different shapes on the screen, hopefully. And we don't, so, because we have a terminate, so instance called after a bad variant access. So this is probably because we terminate up here somewhere, right? So I have my circle ID, my color ID. When I get things that have circle and colors, entities with circle. So it's probably like one of these calls, I guess. Oh, wait a second, let me think. yeah, this actually, you know, makes sense. So I'm trying to convert this particular variant to a circle and a color, and it can't be both, right? It's only one of them. So what went wrong here? What happens is that I either have a circle or I either have a color, and I can't do the same conversion each time. So I kind of have to do something like a visit here. So no, ideally, long story short, when you're working with variants in C++, and this is for the guys who are still learning, you will get into the visitor pattern. So this is how you work with variants in C++. There's a function called visit here, and you can kind of do an overloaded operation where you specify a lambda for each component type that you want, and then whenever a variant that of type, I don't know, circle comes in, it's going to do the lambda that takes in a circle. And whenever a variant that has a type color comes in, it will run the lambda that takes in a type color. So yeah, we can do that, but what we're going to do is probably call this function instead, add pointer t. So let's see. Yeah, so I guess, you know, for the hacky way, we're just going to use getIf. GetIf seems to be what we want to do, right? So it returns a pointer to us. So yeah, let's do that. So we have if, what is it called? Const circle pointer. Circle equals std.get if circle component then we can get the circle information out, right? So we can kind of do something like for now, for laziness, this is not very performant. We're gonna get the circle here, right? So we're gonna do a circle info, or my circle or whatever, and it's just gonna be default initialized. And what we're gonna do is we're gonna do circle equals, oh, this is the draw circle, sorry. So the draw circle is equals to circle. We're just copying the data around, that's it. And we're gonna do the same thing for the other one, the other type. What is going on here? Why can I not copy it? Okay, that's better. And that's basically what we're gonna do. And in here, obviously, we can do draw a circle and then draw a circle. You know, it makes the function a bit bigger, but we just want to get it working right now, right? So this is how we do it. And the same thing here, we're gonna create that rect. So draw rect is gonna be just that, and then if we do an if, gonna do the same shit here. And yeah, this is getting boring, I know, but bear with me because we're nearly done now, I promise. We are nearly done. So we have made a typo here. This should be color. Any other typos that we can spot? Color, circle, rect, color. Yeah, so this is, as you can probably tell, this is not very good for performance because this is copying a lot of data around, especially the variant data. It's just what it's doing. Oh, what am I doing? Draw color. Now let's see. This should compile, maybe not. No matching function for getIf. std.getIf. Circle. Come on, I hope that this would work. Which standard is it? 17, so we definitely have that. What should this return? Const integer pval getIf. Okay. Okay, so this gets this takes in a pointer to the comp. My bad, didn't realize that. Okay. So draw color. There's little types here and there, nothing we can do. Now with a bit of luck, is this gonna work? If it doesn't work, I give up. Yeah, it doesn't work. Does it? It doesn't work, does it? So what is actually going on here? Let me debug this and see if we can get anything going here. Select preset. Let's change it over to Clang debug Ninja. Let's build this and then also change this to Unix style debug. I just want to get this working before I call the stream, you know. I don't want to finish the stream with something that's not working. I hate when that happens. Okay, so now can we run this? And if so, can we see what comes in here? Okay, so the first one, entities with circle. We do have two. We've got two entities with circle and the color. So draw circle. Okay, that kind of makes sense, doesn't it? And draw color ID 0. See, but the ID being 0, what is that? It's black. They can't all be 0, can they? Are they all 0? Did I put them all as 0? I can't remember now. Color ID 3, 2. Yeah, so all the color IDs are kind of coming down to, what are they? To 0, right? So we have draw circle and then we have a draw rectangle here as well. Yeah, so all the color IDs are coming down as 0 for some reason. So are these things actually going in? What are the components in this case? So it's kind of making me think that the color component isn't being not set but acquired, I guess. Here. Wait, what the what have I just done? Classic. Classic me typing my fat finger on keys that I shouldn't be typing. What the hell? Somehow I undid that thing. I undid the correction that I've made there. Yeah, I'm putting a breakpoint on the color component just to make sure that they are coming through. I'm not so sure that they are coming through though. That's the problem. Draw here, and then we have a draw color as well. So yeah, the color is not coming through. Huh, yeah, so the entities with color are not coming through. So registers.get is not actually returning me the stuff that has colors in it. So we're basically just returning, in this case here, all of the rect, right? Yeah, so get is broken. Get is not working. Yay! At least we figured that out. Beautiful, beautiful. So why is it not working? I am getting the color ID, right? Yeah, so I'm getting the color ID there. So if I get a color ID, why are they not being returned in this function? Set intersection. I'm actually interested now in figuring out why. So this is when we call get. Components, we should have two of them. No, we only have one. This is wrong. This is definitely wrong. Oh, this is because it's not in the right one, I guess. There you go. So components should be two now. Second one is the color ID. Next component is the second color ID. So we find an entity, we find a component vector of it here. First and second, contain value is center. Contain value is that as well. Okay, so we found the circle one. So this is the circle one. At this stage, what do we have here? So the back inserter for the result should have some stuff in it, which are just the circles. Yeah, okay. And now in this case, we do have the colors, right? This is what the color should be. There you go. Contain values ID2. So the question is, why isn't this intersecting? So an inter result, we have 2. Ah, I see. Set intersection isn't actually keeping all of the same ones. So this function in C++ is just keeping one of them. The very first one that we find. Now this is not good. This isn't good at all because it's a set. Yeah. Let's see if there's a one that keeps all of them. Yeah, I mean, I know the problem. I'm not going to do this on stream. I think this is probably going to take too long and it's just a bit too boring now. I understand there's people who probably have left already. But anyway, the problem here is that the set intersection is checking the intersection of the entities, but is also only returning the first component it sees, not all of them, right? Because when it does this intersection set, the intersection check, then C++ or the set intersect function here is only keeping the entry that's already there. It's not adding a new one, even though they are different entries. They have the same ID, but they have different component values. So yeah, we got to think of a better way to do this. I think this is not really good. Ideally, right? So the get function would return you just the entities as it was last time. That's fine. But then there will be another function to actually get a particular component for a particular entity, right? So that's, I think spreading these things out would be better. So like we have a function that gets all the entities with like 2 components, or we'll be filtering them out. But then we have a different function that, you know, given the entity ID and the component that you want, it will just return you that component. So yeah, I mean, this is going to be difficult, but we can do that. Anyway, so if you're still watching this, I thank you very much for watching this. Don't forget to like the video. I haven't asked that in the throughout the whole stream, but yeah, please like the video. And I guess I'll see you guys next time. I'm going to be pushing this code to the repository in the description. So if you are interested in looking at all this code that we've done here, the link will be on the description for the repository. So tune in for the updates. Take care. Thank you, Slim. Thank you for watching, dude. And I always appreciate you watching, man. Even if you're just watching me. Good night, Matt. Thank you, Al. So I guess I'll see you guys some other day. Maybe I'll do a stream on. Usually Tuesdays I do a stream, and maybe it'll be like some Golang stream. I've not done Golang in a while, so maybe we can work on Urchin. I also need to do some issues on Golang. I just remembered that. Sorry about that, Al. I completely forgot. But anyway, good night, guys. Bye bye. See ya.